All right, folks, so they informed me that the room is at capacity and that no more people are going to be allowed to come in. So since the audience is here and in some sense captive, we might as well start a bit early. This will give us a bit more time to do questions at the end. Sound good? All righty. Okay, great. Thank you very much for coming. There's a lot of activity here, and so my team at Google and my co-speaker and I are very, very much appreciative of you taking the time to join us. My name is Chad Jennings, and I'm one of the product managers for Google BigQuery, and I'm joined here by Michael Ames, who just dictated his full title to me, so to get it right. He is the Associate Director of Health and Data at Compass, and the Director of Enterprise Architecture at the Colorado Center for Personal Medicine.
That was 90% accurate. Good job.
Well, I'm going to take 90% then. Let me explain a little bit about what we're going to do in this session. We're going to talk a little bit about the aspects of BigQuery and what makes BigQuery an appropriate and useful enterprise data warehouse. We're going to talk a little bit about its agility, elasticity. It's inexpensive enough to be a data lake. It's agile enough to be an enterprise data warehouse. And then, as Michael will talk, it's fast enough to enable interactive queries and ad hoc analysis and full-on, like what we all enjoy, just exploring and trying to find cool stuff in data. Google and Tableau have invested over the last several years to make the connector between Tableau and BigQuery exceedingly efficient. Tableau is one of our best partners. Our offices are literally less than 300 feet apart. And so the Tableau folks and I get together quite a lot to make sure that the connection between the two products is as seamless for you as possible. And what that enables, we'll talk about how BigQuery is a really fast engine for doing queries. But for folks who want to interact with their data visually, having BigQuery and Tableau together make it a tool with which you can scan through terabytes or petabytes of data and do that all in a visual graphical user interface. It's a very powerful combination. So I'll talk a little bit about that, and then Michael will come up and talk about a use case where he's going to show you he's going to bust some myths that are prevalent in the Colorado culture. So get ready for some Broncos references. And then I wanted to make a note about what the session will not be. This isn't a how-to session. So we're not going to get up here and walk you through this is how you do this and that. It's more of a what-if session. If you take this technology of BigQuery and this technology of Tableau and you combine it with the creativity of Michael and his team who are here, this is what you get. So if anybody was expecting to crack your laptops open and actually try stuff right now, this would be a fine time to to attend a different session. But if you're cool with that, then stick around. So I wanted to do a quick show of hands. And Naveen, this is your cue to take pictures. Naveen Punjabi is the manager of partner relations at Google and my valued colleague through these last couple days. So how many of you, raise a hand please, have heard of BigQuery? Okay, so well more than half. That's great. How many, actually, that's really great. That's a better reception or a better fraction than I normally get. Awesome. And then how many of you have, feel like you know what BigQuery is? Okay, I have some work to do. Outstanding. That's why I'm here. And then the money one, how many have actually played with it? Outstanding. What's interesting is I see people who have played with it who didn't raise their hands for the I know what it is. So you are my people for this. Alrighty. Okay, so anyway, without further ado, let me get going on the first question. And I will try to migrate a little bit because this room is so asymmetrical. So I'll stand over here a little bit. Hopefully it doesn't make you uncomfortable. All right, so what is BigQuery? BigQuery is Google's fully managed enterprise data warehouse in the cloud. We have a serverless architecture, which means if you don't want to, you don't have to manage or provision any instances. Google will take care of all of that for you. Our largest customer has more than 100 petabytes in storage. That's a number that I have a lot of trouble wrapping my head around. Our largest single query crunched through 2.3 petabytes worth of data. So this is a system that crunches enormous amounts of information really, really quickly. And Michael will talk later about what that enables for you, the Tableau BigQuery users. The interface is SQL. For those of you that want to speak Tableau and not SQL, that's fine because of that connector that I mentioned. And the storage, a lot of people actually forget this, so we have to spend a second on it. BigQuery has compute resources and storage resources. And the storage for BigQuery is actually super price competitive with everything else out there. And we take a lot of pride in making that storage fast, durable, and highly available. Okay. So BigQuery has had a bit of an identity crisis for the last few years, and Google is fixing that now. So BigQuery is enterprise ready, and BigQuery is an enterprise data warehouse. It's focused on analytics. It's not an OLTP system, OLAP. And these are the reasons why people tend to come to BigQuery. I'll spend a fair bit of time talking about agility. Because BigQuery can crank through so much data so quickly, and because it's so cost competitive, you can put an awful lot of data, whether it's a data mart or a data lake or an enterprise data warehouse. The tool is appropriate for all of these different functions. I see a lot of block diagrams when I go and talk to customers, and they've got this box over here and this box over here, and this is our data mart over here, and then around the corner and back in the other side of the room, there's a data lake that really only Joe knows about that, but he left the company 2 years ago, so really hoping that thing stays running. With BigQuery and Google's cloud Google Cloud, you can bring all of that together and have one simplified block diagram. I know engineers like complicated ones, and consultants love complicated ones, but people who deliver solutions really like simple. The value that Google provides in this that we think is very different from how other companies work is we're trying to make all of this super duper easy. And by doing so, by offering a serverless and fully managed product, this is what folks have to do now. If they're like managing a Hadoop cluster or tending an on-prem system, they've got deployment and configuration and patch upgrades to software and all sorts of things that you've got to do just to keep your computers fed and watered. And Google's position in the market is, we're super good at doing that already, right? We have Gmail, we have YouTube, we have apps. We're good at running distributed systems. So tell you what, we'll just do it for you. Sound fine? Excellent. So you load your data up, and Google will take care of 9 or 7/8 of this pie chart. You just write your code and then do your gain whatever understanding you can. So no-ops, that's a term that we use for BigQuery a lot. It's a no-ops system. It's fully managed. You guys don't have to worry about using the system. You just have to worry about getting the genius out of your data. So just to make sure that Chad isn't all hot air, we are going to do a demo. Now, this is a super simple query. I'm not here trying to talk about how Google engineers can write 4,000 lines of SQL to compute all sorts of things. This is a sledgehammer, and this table right here is a big, fat nail. It is, in fact, a 1.09 petabyte nail. And we are going to scan through that with a very simple where if clause before I have to leave the stage. So let me go ahead and get that one running. To the skeptics in the audience, please notice this right here. I'm not caching the results. So this is actually running. So what's happening now is this query is being parallelized across thousands of workers that you don't have to spool up. You just write your SQL and press the big red button. All right, so let me scoot back. Okie doke. So we just had a big launch at the end of September, and these are the features. And I'll talk about them all very briefly, and then I'll get into a couple of them in a little bit more detail. So BigQuery wants to be friendly to the enterprise. Previously, we'd been more of an ad hoc engine, and that's actually a really valuable functionality to bring to people. But enterprises also want to be able to run production workloads and things that aren't necessarily investigating secrets inside of data. Just, hey, produce that sales report, but do it really fast, do it every Monday, and then move on to the next thing. And so the engineers on our team and the product management team have been working hard to make BigQuery fit into that other model. And these are a bunch of ways that we went about doing it. So flat rate pricing, I'll talk about it a little bit. Sorry, it's not, it's not a technical thing, but in terms of enterprise customers, it's really impactful. The interface is standard SQL. There used to be a thing called BigQuery SQL. It's still going to be a thing. If you guys have workloads running in BigQuery SQL, that's no problem. But we also have a standard SQL dialect that's going to be richer feature experience. For connectivity, so you don't have to do any gymnastics to rework any tooling that you have, we have ODBC and JDBC connectors that just launched. A big weakness, or big gap that we've filled now is BigQuery didn't do update and delete for a long time. I heard a lot of complaints like, hey, I was reading your documentation, but when I saw it was append only, I stopped. So you don't have to stop now. We have updates and deletes. We have real-time monitoring with Stackdriver charts, and for the security conscious, we've integrated with Google's cloud-wide identity access and management. I'm going to talk in a little bit more detail about these two. If you're curious about the other ones, come find me after this session. I'll be just hanging out in the hallway. So flat rate pricing. Previously, BigQuery was an on-demand pricing model, which meant you paid for the bytes you used, and you didn't pay for the bytes you didn't, which is really different than the way pretty much every other enterprise data warehouse works, whether it's on-prem or in the cloud. We thought that was pretty awesome, and we hammered that message home for a long time. Except enterprises come up to us and say, well, the storage is predictable, but our analysis can vary back and forth in a given month, and I'm on a budget, so please don't talk to me about saving money in March if I go over budget, even by... Did this just working? No. So we introduced flat rate pricing, which is a flat monthly fee. You can process all the data you want. You get access to a specific set of what we call slots, which is our measure of compute capacity. And those slots are yours. If you're not using them, we might let somebody else use them because it's a multi-tenant system. But as soon as you want, you've got right of first refusal. And you write a query and pow, those slots go to your workload. And you can run as much work through those in a month as your skill and your tasks allow. Since we're selling our warehouse by the slot, we needed to show people what their slots were doing. So real-time monitoring in Stackdriver. These charts here are available online. You can go through and click on the Stackdriver icon in the console and actually log in for these right now. And this chart here shows a time history of how many slots you use at a particular instant in time. So you can look at this and determine whether your capacity is overburdened or underburdened, or whether the hours from 2 to 4 in the morning need more work scheduled for them. But it allows you to manage capacity a little bit better. And there are a whole bunch of other, which I won't go into, there are a whole bunch of other parameters that you can have a look at. So we're very, very proud of all of the technology that we've developed, but we're most proud of stuff like this. When we deploy these kinds of, or this technology into our customers' venues, we often find, as a matter of fact, most of the time we find some really profound improvement in the way they're able to do work. So Lloyds Bank found that their processing pipeline went from 96 hours to 30 minutes. So I don't do divide by 24 very quickly, so I did this one offline. It's 4 days versus 30 minutes. So it's like, imagine this. You've got your query, you're sitting down, just had your cup of coffee on Monday, and you write the query, press run. Then, now you go off, you grab a second cup of coffee, you come back, and it's finished. That's the case with BigQuery. Case with their on-prem system was you press run on Monday, and then Thursday after lunch, you get your results back. So it's a completely different world. And that different world was reflected by Mr. Johansson at Spotify. I'm pretty sure he wasn't including things like birth of children or weddings in this appraisal that BigQuery was the best thing that ever happened to him. Some of the folks at Google figure that he spent a couple nights on the couch because of this. But the team is really happy to receive those compliments nonetheless. All right, Google's not so proud that we think we can do this all by ourselves. So we're partnering with a host of different companies. I mean, a lot of these guys you see here, right? Top of this table, anybody recognize that one? So Google knows that to provide this functionality, one size does not fit all, one tool does not fit all use cases. So we've got to be really conscientious about building a lot of options for customers. Splendid. So 1.09 petabytes processed in 152 seconds. So what's that? 120 is 2 minutes. So this is 2 minutes and 32 seconds to process a petabyte worth of data. Okay, that's not bad, honestly, really. Right? Think about what you would have to do to process a petabyte worth of data with your on-prem system. First, could your on-prem system do it? Ever? No. Maybe. Whatever. If you're going to do it on a system where you have to provision stuff, right? If you're going to move from tens of terabytes to a petabyte, you're on the phone for a week with whoever that other company is, making sure that the capacity is provisioned and whatnot. Here, you just write the stuff down and press the red button, and you're off to the races. We're going to bang that drum a lot, by the way, just in case you hadn't noticed. All right, so the metaphor for this is BigQuery has always been like Superman, right? It's always had these super duper data processing powers. Ever since it was a little baby enterprise data warehouse way back when. But the team has been working hard to make it look a little bit more like Clark Kent. And what I mean by that is, Clark Kent is the one that can go about in the world and interact with companies or interact with people. In the metaphor here, BigQuery can exist in your enterprise environment without making you do a bunch of work just to make it crank along. However, when you need it, you can empower your data analysts or your data pipelines with the BigQuery superpowers to crank through data when you really need to. So, so that's how we're thinking about it. And then if you want to amplify your big data superpowers, think about what we didn't have to do to run that demo, right? No provisioning, no capacity calculations, no planning, no calling your vendor, no indexing or designing keys, right? You just load data, write your SQL, press the big red button, get results. To be honest, now the Google engineers look at this and like, okay, that's no problem. Well, to be honest, for me, writing the right SQL can be a big problem. Loading the data sometimes can be a problem. Interpreting the results can be a problem. So you can't trivialize these 4 steps just by counting them off in less than 10 seconds. But fortunately, there are tools out there to help you do this kind of thing. And so Michael's going to take the stage now to talk about what happens and what kind of insights you can get when you start cranking through data at the volume and the power that's available with BigQuery, and then visualizing it inside of Tableau. All right, and to do this, we need to swap.
Not yet. I still have some slides.
Oh, okay.
Yeah. So my mic is working. Hi.
And mine.
All right. So the second half of this, it turns out that I can't accept any help with travel expenses from Google, which as a poor nonprofit university I really want to do, if their logo is on our slide. Turns out that is the thing. So we're switching to, I want you to imagine in your minds, it's a completely different slide set now. Okay? I'm certainly not here paid for or here to endorse Google, but I'm here to talk to you about what our experiences have been combining the power of BigQuery, as Chad has just described to you, with the power of Tableau, that all of you know better than I do, being a relative newcomer to Tableau. Let's talk a little bit first about Colorado, which is as beautiful a state as you believe it is. Whatever your image of Colorado is, if it's lovely, then you're probably right. What a lot of people don't realize is that those big, luscious mountains are actually only in the western half of the state. People think of Denver as being kind of nestled in the mountains, and that's wrong. We're actually in the western edge of this big, flat eastern plain. So now whatever image you have of Nebraska or Kansas, that is also Colorado. And that's where we are in the Denver area. Specifically, we're on the Anschutz Medical Campus of University of Colorado, Denver, and some other stereotypes of Colorado that you may have heard of. We have some pretty excitable sports fans. In fact, having lived in 4 or 5 different states, I've never been in a place where people are more enthusiastic about their pro sports teams than you find them in Denver and surrounding area. Anybody ski? You should all come to Colorado and ski. Up in those mountains, we have these beautiful, deep, luscious, powdery snowfalls, dozens of ski resorts to choose from. And in recent years, we have something else cropping up all over the place. Looks something like that. I hear that last night we added a couple of more states to this dubious club of medical and/or recreational marijuana use. I'm putting this up here because these are probably things that you know about Colorado and have heard about, and we're going to actually do some data analysis that relate to these things later on in the presentation. But before we do, and while you stare at that, most beautiful of all slides I've ever created, I want to tell you how excited I am personally to be here giving this presentation, because we started playing with the Google Cloud Platform and BigQuery specifically about 1.5 years ago. Literally me in my pajamas at night sitting on the couch running tests and experiments to try to see if all of this sales pitch that, Chad isn't a salesman, but slides similar to what you just saw in the first half of this, if that sales pitch was actually real. Because if it was, we believed that we had an opportunity to do something transformative. We had invested heavily in a very traditional on-premises system for our data warehouse. It was not meeting our expectations in every way that we imagined, and we started to take a peek at alternatives. 8 months ago, we kicked off a focused, under-the-radar pilot project in order to actually put this technology through its paces and to find out if when we put real data in there and we build out all the components that we have to operate an enterprise health data warehouse, does it hold up to the marketing hype, and will it actually do what we need it to do? And I'm going to show you some of the results of that pilot, but for 8 months, we have not been able to talk about this with anybody. I'm really happy to say that exactly 1 week ago, our steering committee approved, based on the results of our pilot, a project now to completely transition, decommission our on-premises infrastructure, and move the whole thing into the cloud. We had an awkward conversation with our on-premises vendor, and once that was done, we're able to bring this in the open. So this is the first presentation. You are the first public group who's hearing about what we're doing and what we've learned about working with Tableau and Google BigQuery. And I can't tell you what a relief that is. Thank you. Thank you. All right, so moving, let's see, I hit the wrong computer here. So who we are, within the university is this organization called the Colorado Center for Personalized Medicine. This is a relatively new organization that's bringing together some cool stuff. Anybody here from health analytics or healthcare organizations? Great. So some of you will know some of what we're talking about here. Now, as a university, we're heavily research focused. We have partner hospitals and billing organizations on the left. Within the Colorado Center for Personalized Medicine, we're taking data from patients associated with those hospitals, and we're doing a bunch of things with it. We have a highly advanced DNA sequencing lab. We're hoping to do full genome sequences on hundreds of thousands of patients over the next 5 years or so. We have a clinical molecular testing lab where for certain limited cases, you walk into the hospital with a certain kind of disease, we can look at your DNA and we can help doctors to do a better job diagnosing and prescribing treatments to that disease. We have a 700-core parallel processing monster for doing computational analytics on all that DNA. Once again, for those of you who don't work in this field, you've heard about how complicated things like DNA and genome sequences are. However complicated you imagine that is, it's much, much worse. And it requires huge amounts of storage and computational capacity. And there on the bottom is where my team operates. So Health Data Compass is the Colorado Center for Personalized Medicine's enterprise health data warehouse. And what happens is all this collection and processing data that happens upstream from us gets blended together, and we become the integration and access point for researchers, for doctors, for administrators who want to advance the cause of healthcare, find breakthrough medical discoveries by bringing all this data together and analyzing it in new and interesting ways. I'm happy to have two of my team members here, Ju Wang and Michelle Edelman. For the other members of my team who are watching this on rebroadcast later, Linda, Leah, and others, thank you for your contributions of this. The analytics and the slides that you're going to see later on were the result of this team and a great scrambling effort that happened mostly in the last week. Right now, our use of BigQuery and Tableau is limited to Health Data Compass and the data warehouse. But we're excited about this technology, and in my other role as Director of Enterprise Architecture for the center, we expect to see more and more of those little hexagon icons showing up around other areas of the center. Okay, so high level, we had slide after slide after slide of detailed findings, because remember, this was a pilot project where we went deep and we pushed the boundaries of the technology in light of what our needs are. Tough to even bring it down to 5 or 6 bullet points here, but clearly the strengths that Chad was talking about in being a 100% no-ops database, that's legitimate. We don't have to manage VMs. When you have a great BigQuery or a very small query, the BigQuery engine automatically scales up to provide you with the parallel processing power that you need in order to complete those queries quickly. 99% compatible with SQL out of the box, and that number improved over the course of the pilot, and we believe is continuing to improve. ODBC, JDBC, REST, whatever mechanism that you need to use in order to access the data is there out of the box. And I should mention here that Tableau has a native BigQuery connector, so you're not having to get to BigQuery through some third-party ODBC. You can select BigQuery from the list and connect directly, and that works really well. Of importance to us, BigQuery is also HIPAA compliant. Again, so for the health folks in the room, if you're dealing with sensitive data, they'll sign a business associates agreement, and we are confident in the security of the system. Weaknesses that we found that are a little bit frustrating to us. DDL, things like create table statements, alter table statements, creating temp tables and stored procedures, those kinds of things aren't supported. And the reason why, as we have sort of come to understand it, is that if you think about it, in a lot of cases, if you've got some big, hairy SQL script to process data and you're firing off temp tables and those kinds of things, the reason you're doing that is usually to compensate for limited resources and performance problems in your database server. With BigQuery, there's some effort to kind of reimagine the way that you develop SQL. Don't worry about creating temp tables in order to optimize performance. Write that SQL select statement, however ugly and hairy it is, hand that off to BigQuery and let it do the work of optimization. And that works really well. However, legacy code won't be plug and play within BigQuery, and that's frustrating. Or open source things, if you've got some amazing analytic package that you're getting down from GitHub and it's got some DDL baked into it, then that's not going to work out of the box. And we'll see where that goes eventually. Also, another thing, just to sort of lower your expectations, we're talking about how fast this is, but it's designed for being fast at scale. There's like a 1 to 3 second, 3 seconds of that 150 seconds that you saw in the demo, you're going to have that even for a little tiny query. That can be frustrating if you're doing dashboards and you're looking for instant refreshes. But that is part of why we feel like, oh yeah, I'll come to that in a second. It's part of why we feel like Tableau, and we'll talk for a minute about how Tableau sort of helps with that problem. I am assured by the Google team that they are working on chipping away at that kind of fixed ramp-up time. So there were just a couple of slides at the end of this pilot that were really the selling point to our steering committee. Here's the first one. This is on performance. If you look at the left side, this is end-to-end ETL. So this is starting with when we extract data from the source system, going clear through the extract, the loading process, getting it into the destination database and transforming it there into our target schema. The legacy on-premises system is there in red, and the Google BigQuery-based system is blue, and you can see we have about a 50% performance increase. A couple of notes. The performance increase on the BigQuery side, remember this is end-to-end, so that includes taking this data, pushing it up through the internet pipes into the cloud. So there's upload time in there that is not on the on-premises bar, and we still have improved performance. Secondly, whenever I put the slide up there, my developers are like, yeah, okay, but tell them, make sure you tell them, because you know how engineers are. They want to take pride in their work. The red bar is after hundreds of hours and many thousands of dollars in working to optimize performance. The blue bar is the performance that we got by just dropping the data into BigQuery and saying go. with effort around performance optimization, we believe that delta will get even bigger. Second thing, we have to do this thing. Anybody here know what a master patient index is? Anybody worked on something like this? Some of you healthcare people? You guys don't count. We have multiple hospital systems, and sometimes you might have one person who goes to each of those, and what our goal is to figure out when that one person is actually the same person, and we want to connect all their data together. So one of the things we have to do, if you can imagine taking 6 million patient records and doing like a massive cross-join on that data and some fuzzy matching to see if Bobby Jones, who checked into our children's hospital with a broken arm at age 22, is the same as Roberta Jones, who showed up at the adult hospital with some disease, the children's hospital at 12, and then showed up at 22 to the adult hospital, that would have been awkward, with some other disease. Fuzzy matching, it's a complicated process, and traditionally this is done by firing up some big virtual machine and running some procedural-based code that does SoundX matches and all of these things. On our legacy system, that took 8 hours, that process, to run at an initial investment cost of about $250,000 for the system that did that data processing. We said at the outset of this, let's challenge ourselves. What if we could do this in BigQuery? Is it possible to encapsulate all that logic in just a couple of hairy SQL statements? In addition to standard SQL, BigQuery supports user-defined functions in JavaScript, which gave us the ability to do some of those fuzzy matching algorithms. And you can see there, when we were done, we were able to reduce the time of processing from 8 hours down to about 15 minutes. And the cost, it costs us every time we run that, which we'll do about once a day, about $1.50 a time. This is absolutely transformative, and it goes beyond just, wow, we can process the data faster, but we can do it so much faster that we can innovate and change the way that these problems are approached. Here's the other one that sold our steering committee. These are our annual operating costs. So this includes things like keeping the hardware up to date, the software up to date, the software licenses, the personnel to support it. And you can see that we achieve a 60% reduction in annual costs going from our on-premises system to BigQuery. We believe, I'm not giving you the numbers there in good taste, and we're not going to talk about what the numbers are, but our experience is that, and it is our belief that whether your red bar is something you measure in 4, 5, 6, or 7 figures, you would have opportunities for similar advantages in savings. Now, this is where I'm going to pitch something a little bit different than what Chad did, because he was talking about fixed rate costing, which for those of you in big companies with picky CFOs and accountants who want to be able to know every month what the bill is, that's a good advantage. But for us doing a pilot, the only paying for what you use scenario was really important. We think of this as zero depth entry. You can go in to just your toes if you want and back out if you need to. Or if you're feeling good, you keep going into your knees. You pay a certain amount based on the amount of data that you're storing and the size of the analyses that you're running. And this was so low for us that in the first few months of our pilot project, I had forgotten that I put it on my personal credit card. One of those nights in my pajamas signing up for our project, right, 1 a.m., and I didn't have my university card by, I put it on my, and it was only much later when we started dealing with much bigger amounts of data and more resources on the cloud, and I got a credit card bill for $5,000 one month, and my wife said, "Why are you giving $5,000 to Google?" that we realized we had a problem, and that makes this ideal for pilots, for experimentation. If you want to try this out, you don't need your CFO's approval. You might not use your personal credit card, but you might if you need to. Ultimately, for us, it was worth it. Okay, I keep hitting the wrong button here. So when you put these things together, we see these tools, Tableau, which you know so much about, and BigQuery, which hopefully we're learning about. Part of what makes this sort of great synergy is that these tools really come from the same type of thinking. They're both intended to be very fast. They're both intended to support iterative thought processes and the idea of exploration, that when you start out asking a question, you probably don't know what question you should be asking. And it's only when you get through those first couple of iterations that you start to refine your hypothesis and realize what you need. And every answer also opens up 10 or 20 or 30 more questions. We're going to show you some examples of what that looks like with, again, some sort of lighthearted analyses that we've done on real data with Google BigQuery and Tableau. So these are the three scenarios that we're going to look at. Colorado health myths. We're going to switch to my screen and not come back to these slides. So I'm going to read through these now, and then we'll hit them one after the other. Snow bunnies make snow babies. Or, what do Coloradans do when it's cold outside? We'll look at that. Will weed make you walk into walls? Some people think that maybe it does, and we'll see if the data supports it. And finally, just how ravenous are these Colorado sports fans? Broken arm during the game? Hold on. Wait till the final touchdown before you head to the emergency room. We're going to test these out with data and see what we can find. So now is when I come to push this magic button. Well done, AV folks. Appreciate it. Okay. Look at the resolution here. I think we're okay. So let's talk about snow babies. Part of the purpose of this is to illustrate another thing that hasn't been mentioned with BigQuery. We talk a lot, I've heard a lot of talk in the Tableau conference about the ability to join different data sets at the Tableau level. BigQuery's architecture is such that while you certainly have control and security rights to lock down your data and make sure that nobody else sees it, you also have the ability to say, here's a data set that I think is useful to other people. I want to make it available to other people. And joining a BigQuery data set from somewhere on the other side of the world to you is absolutely trivial. There's no setting up DB links. There's no importing data. If you happen to know the data set name and the table name of the data that you want, you can link to it. And Google provides daily weather station data from 9,000 weather stations around the world. Think of the cool things that you could do with the new Tableau mapping capabilities by linking that up with this daily weather data and comparing that to your marketing efforts and your sales efforts or things. What we're looking at here is it true that when we have big snowfalls in Colorado, 9 months later we have babies? Okay? The blue lines represent the amount of snowfall, and the orange line there represents birth rates coming 9 months later. So if there's a correlation, we should see them on top of each other. We took a look at this data, which was first half of the year 2014, and you can see there's some kind of tantalizing peaks here, but there are also peaks here that don't seem to be related to where the data is. Notice here that we're looking at total snowfall. So that's how much hit the ground, but Colorado's got a moderate temperature. Often it hits the ground and melts. So thinking we wanted to look at this a different way, we changed this from snowfall to snow depth. Oops, did I hit that right? No, I didn't. Hang on. Okay, now the numbers look different. And by the way, this is a combination of data going back to BigQuery Live and data that's been extracted into Tableau. Some of the expertise that Ju is building and developing is sort of knowing where that right balance is. But as we look at snow depth, which is the amount of accumulated snow on the ground, which you would think is probably what keeps people inside, now we start to see some interesting correlations here. These go down, and when the snow depth goes up, we see an uptick in babies, and then as the snow drops off, we see this significant drop-off in snow, right? So we think, ooh, exciting, maybe there's a correlation here. But it's always important to expand your view of the data. And this is what happens when we look at this over the course of 2 years and multiple seasons. As you can see, this part of the graph, which is what we were looking at before, when compared to this, really suddenly that correlation isn't as exciting. And you know, you're all Tableau people. There's statistical ways to evaluate this, but we're using our eyeballs in order to look for these patterns. And so our hypothesis goes from, oh yeah, we think this correlation exists, to oh no, it doesn't. And we thought, if there's a question we can address, make sure we didn't. So then we thought, maybe we're doing this wrong, and the problem is there are probably other reasons why we might be creating snow babies in the summertime. And rather than comparing what's happening in the summer and the winter, what if we just look at winters? January, February, March are our snowiest months. If we take straight averages on those two, comparing these over a couple of years, you can see much bigger overall snowfall in 2014 versus 2016, but no correlation in the births. We think this one is busted, right? Now, there are probably 100 other causes and effects that could be looked at here. You are the kind of people who I hope are sitting there thinking, oh yeah, but did you look at this? Did you look at this? Did you look at this? No, because we only had a week to build this stuff. But the exciting thing is that if there were other things for us to look at, we could do this so easily, and at no point does it take a phone call to the DBA. At no point is it a worry that we're going to run out of space. And we're using a data set from Google that is already available to us and required nothing for us to build up in order to get that weather data. Let's look at our second example here. So this one's from a real request that my team received from a couple of emergency room doctors. Hold on, I'm going to go back to here. A couple of emergency room doctors, and they said, we think there's something going on because we are responsible for treating patients who come into the emergency room with broken noses or broken jaws, facial trauma injuries of some kind. And it was their observation that after Colorado legalized recreational marijuana, there was an uptick in the number of people showing up in the emergency room with facial trauma. They didn't have a good theory as to why. And when you think about it, it's kind of hard to imagine why, because if anything, doing a little marijuana should help you feel calm and relaxed, right? So we don't know, are people walking into walls? Are you hugging the wrong guy and getting punched in the face, right? There are a lot of things that could be behind it. We had no idea. But we start with seeing if the data even supports the hypothesis. And we ran a query and got this initial result. Orange is pre-legalization, blue is post. Just take a moment and let that sink in. We're looking at total number of facial trauma diagnoses in the emergency room, pre and post marijuana legalization. Okay, again, you guys are all out there thinking, who has a hypothesis or an idea why this would be? Chad warned me. He says, data people don't participate. You guys should participate. Okay, so population growth. It might not be related to marijuana at all, but simply more people in the population showing up. Good. Other ideas? Obamacare happening around the same time. People are slapping each other really hard in their political arguments. I don't know. Could be anything. It is always important to check the denominator, right? Now, that would be quite a remarkable population growth, but that hypothesis is pretty close to the truth, because look what happens if we look not at total facial trauma diagnoses, but as total people showing up into the emergency room. I'm going to click the button and watch how the bars really don't change very much at all. And in fact, this wasn't a factor of lots more people showing up to the emergency room, but purely a factor of, during that time period, our hospital system acquired 3 new sites and integrated their data into ours. And you can see how something like that, when you're working on trying to answer a question and you think that there's some sort of physical causality, in this case, it was just sudden availability of data. Now, that doesn't explain why the doctors thought that they were seeing more instances of these, but it does mean that our first look at the data was wrong. Let me pause just a minute, though, to help you understand why we're even bringing this up as an example, other than that it's fun to talk about marijuana. We, in the course of doing this analysis, and by we, I mean Ju here and Michelle and the other folks on my team who are doing this, went through many, many, many iterations on this data. Both iterations in terms of how we visualize it in Tableau, probably dozens and hundreds of times before we got to some sort of useful information, but also iterations on the data mart level within BigQuery. How many of you, if you need to do some transformations and get your data into a different schema in your database, have to make a call to a programmer or a database administrator? Some hands, right? This is an issue, right? How many of you, though, have like super user privileges on your Oracle database and or SQL Server or whatever it is, and can go in and create new schemas and things like that without talking to anybody? A few. So a lot of you are in the middle, or you're not doing this kind of work. The reason why we route things through the database administrator is not because they have some special magical skill that you as a data analyst don't have, but it's because we're worried that you're going to write a query that's going to take the system down. You're going to do a 6 million record cross-join and not realize that doing that is going to bring the whole system to its knees. Part of the BigQuery architecture the sort of infinite scalability of the BigQuery architecture means that that risk is completely gone. So we, with great confidence, give members of our own BI team privileges within BigQuery to create new data sets, build new transformation views, and persist new tables. And that happened multiple times in this process as well. This kind of analysis only works when you iterate, and to do that well, you have to have tools that are fast and flexible and allow you to do it. Okay, moving on. Oh, and so one point of comparison, the query that sources this data, when we did it the first time, before we had BigQuery in place, and we were running it against a dedicated SQL Server machine with no small amount of capacity to it, ran in about an hour and 48 minutes. Moving this onto BigQuery, that runs in about 30 seconds. And you can see how that would make a huge difference in your ability to ask these questions over and over. All right. So we have a problem here, which is that the denominator is changing. We want to explore it differently, so we normalize it. And now we are looking at facial trauma before and after legalization of marijuana per 10,000 people showing up in the emergency room. And you can see, if anything, it has gone down. So there is no data to support this hypothesis that legalizing marijuana is increasing people showing up with facial fractures. Just for fun, and again, I hope you're sitting there thinking, well, did you look at this, look at this, look at this? One thing that we looked at was dividing that up by gender to see if we can understand those changes, and this is interesting to me. First of all, men break their faces twice as often as women. Good job, men. You make us all proud. Secondly, if there is any pattern in here, it's that the rate at which men are breaking their faces has decreased since we legalized recreational marijuana. That's not a political statement. I'm just saying this is just what the data is showing. And we can go out here, we can branch out 20 different ways to explore that data in more detail. But we're gonna look at one other example now. So we have looked so far at two myths, and our conclusion is that the data doesn't support it. We think they're busted. Let's look at one more. Denver people love their Broncos. And there is this idea that the rate of people showing up at the emergency room slows down during NFL games. Which means, if you're getting rambunctious early on in that game and you break your face, men, or whatever the injury might be, you're actually making the conscious decision not to go to the ER until after the game is over. Okay? That's how serious we are. So this chart is looking at cumulative check-ins to the emergency room, and you can see these vertical bars here that show pregame, start of the game, and end of the game, and we are looking at Super Bowl from 2012. The dotted trend line in the middle is there to help us sort of gauge the way that slope changes. That slope should increase if more people per hour are checking into the ER. It should decrease if fewer people are. And as you can see, during this Super Bowl 5 years ago, there wasn't much of an effect. We see potentially a little effect in 2013. You can see here, once we hit pregame, that this curve starts to level off a little bit and crosses the trend line just toward the end of the Super Bowl and then pops back up right at the end. But still probably not enough to actually say we've got a pattern. Look what happens in 2014. Now we start to see a little bit of a hockey stick effect. We're right at pregame time. The rate, the slope of this line, which again indicates kind of check-ins per hour, decreases, continues to decrease through the game, and then picks up again to where we'd expect right afterward. It lets off here, we figure, just because it's getting late. What happened in 2014? Why is this different from the previous years? First time in 15 years the Broncos made it to the Super Bowl. And it was such a brutally, horribly embarrassing, disappointing game. For any of you who remember, literally from the first hike of that ball, we were bemoaning our state, the state of our state, throughout that game. And we can see that trend here. Now, there is a possible confounding factor. Maybe this is because of the game. And as we look at, at these other years, we see a similar kind of pattern happening. But maybe this is just what happens in Sunday afternoons in Colorado, right? This is about dinner time when the pregame starts. And as it gets later, maybe people are calmer and they're not getting hurt. So maybe we really don't have any reason to think that the causality here has anything to do with the Super Bowl. We will take a look at that. And so what we did, and again, this is the kind of thing that involves going back to the source data, creating a data mart, which we were able to do very quickly. And we have 3 new lines here. The red line, which in this one is on the top, is ED admissions the Sunday after the Super Bowl. Blue is Super Bowl Sunday, and red is the Sunday before. And the idea is to compare this to the Sundays on either side to see if there is anything different.
Sorry, Michael, what does ED mean?
Emergency Department. Thank you. So to see if there is anything different on Super Bowl Sunday, and again, 2012, we don't really see any different. Those lines weave in and out. They follow basically the same slope. Let's go back to 2014, first time in 15 years that the Broncos were at the Super Bowl. You see a trend in here? Remember, the orange and yellow and red lines are the Sunday before and after. The blue line is the Sunday of the Super Bowl. This week, when the Broncos finally made it to the Super Bowl, there was a definite change in the rate of people showing up to the emergency room. And if we go look at last year's Super Bowl, same thing. We actually have data now that we believe points to a new hypothesis that says, yes, Coloradans will wait until after the game to go to the emergency room, but only if their own team is playing. And that effect is most pronounced the longer you've been waiting for that team to play, which is why we see it so strong in 2014. Here's another way to look at it. You're going to have to turn your heads a little bit sideways for this. But if we take the years that Denver was not in the Super Bowl, these rows here show before, during, and after the game. And as we would expect, after, and so red is the Sunday after, blue is the Sunday of, we see that there's really no difference. Sunday of in 2013, the bars go down pretty steadily. Sunday of in 2015, the bars go down pretty steadily. These are total admissions during this time period. The years that we were in the Super Bowl, you see a different pattern. Sunday after, the bars are still going down. Sunday of, look at that dip. Look how we've got a dip during the game, okay? We're as crazy as you think we are, all right? The point here is not so much to point out how crazy we are, but to say this is the kind of work that we do when we're doing biomedical discovery as well. We start with a hypothesis, an observation often that a scientist has maybe heard something of in a conference or read something of in a journal, and they're coming up to us and saying, hey, does our data reflect this? And I want to look at that. And Michelle, who's one of our lead analysts, understands that that first question is the start of a long conversation, and that we are going to iterate and iterate and iterate on that data, not because we can't seem to get it right, but because every time we answer the question, 10 new ones show up. And we can do this so much more effectively operating on technology that allows you to do that fast, inexpensively, and flexibly. And I think that's all I have for my slides. We should switch back. Which button is it here? Okay, not that one. Oh, is that what it is? All right. So with many thanks to Chad and our partners at Google for helping us get here, we still have 15 minutes in this session, and I think we can take questions if you have them. So I think we were going to have a volunteer with a microphone because they're recording the audio. Great. And can we turn on the main lights in the room?
Yeah, and just before we get to that question, I wanted to ask Michael, the plans that he has to, like the analysis that they're going to start doing is not about marijuana, sex, or football. And so, Michael, would you take, I'm expecting, would you just take a minute and talk about how you guys plan to use the GCP in the future?
What we are actually doing, absolutely. So let's give folks just a moment. Folks who need to leave, we'll let them get out of the room to sort of quell the background noise a little bit, and then we can jump into this and to some questions, okay? and we appreciate you coming. Oh, I think the last slide actually had some contact info, but there are ways to find us. I don't know if you can put that up. Okay. So what we're actually doing, while this was fun and sort of a demo of the capabilities of the technology, is we are working on ways of diagnosing and treating disease by looking not just at what we call the disease phenotype, or the clinical view of the data, which is the stuff that the doctor can see about you when you walk in, or that the doctor can determine of you from a basic blood test or other test of your health vitals. But it is generally believed among the biomedical community that almost every disease is affected by, in some way or another, by your genetic makeup. So again, part of what the Colorado Center for Personalized Medicine is doing is trying to bring together hundreds of thousands of records of complete DNA samples, and then we link those back to everything we can get our hands on about that patient. The diagram that I showed you had a couple of hospitals and a billing organization, but there are many other data sources out there that can tell us things about the health of our patients. And so we are linking that data together, and then we're making it available, again, to PhD researchers and to doctors and people who do administration in order to start exploring the data and developing hypotheses where they can say things like, whenever we prescribe someone with this kind of cancer, this type of chemotherapy, they seem to get worse and not better. Why is that? If we can look in the data and see what that group who is doing worse has in common genetically, we can then study that further, prove it out clinically, and integrate with things like the hospital medical record systems to give better advice to the doctors on how to treat that patient. So when they say, I've got this patient and they've got this kind of cancer and I want to prescribe them chemotherapy, the medical record system would know about your genetic makeup and can pop up a message to that doctor and say, be aware, this person's genetic profile is of a type that is going to make this particular treatment that you have described go worse for them. Please don't do this. Please use this alternate treatment instead. And in that way, we improve healthcare, we reduce the cost of treatment, and we help patients get better sooner and faster. And that's really the end goal of what we're doing.
Yeah, and Google in general and BigQuery in particular are just so honored to be, to be part of their team and to help them do that. I mean, obviously that's work that just should happen in the world. Anyway, so yeah, we're really delighted, really delighted. Anyway, with that, you have the floor.
Guy with a microphone. Is there a switch?
We can paraphrase the question if you want to. Go ahead. We'll repeat.
Yeah. So we have probably spent $1 and an hour on security questions for every $1 an hour that we have spent on actual functionality of the system. And to be clear, it's not that we have any doubts about the security that's provided by Google. Early on, our security officers did an in-depth analysis of Google's security, and I should have repeated. The question was to elaborate on security, and when you're dealing with this much data and this many connections, what kinds of problems and things do we have? Is that about right? Yeah. So early on, we convinced ourselves that nobody in our little group of technologists and engineers at the university is going to do a better job securing the data than Google's team of 500 dedicated security engineers at their data center.
600.
600, excuse me. Plus, I think in the South Carolina data center, actual alligators on property.
I can't confirm that.
There is. Actual alligators on property. So that's a level of security that we can't provide. And we're convinced of Google's Fort Knox-like security if the data is in there. However, this is a platform, meaning that we develop software on top of it, and we can do that wrong. We can take that nice iron-bolted door to Fort Knox, and we can accidentally leave that open and let people get in and get data out. So because we are early among our peers in adopting this technology, we invested heavily in outside consulting on our own analyses in order to make sure that we know where all those doors and windows are, how to keep them locked shut. So in the end, we are confident that Google's security is sound and that the security controls provided to us are robust enough and granular enough that we can ensure that people are only allowed to access the data that they're actually authorized to access, which I think is ultimately the end goal. But that there is a significant amount of effort on our side in making sure that we have configured things correctly so that we don't accidentally expose data to somebody that we shouldn't. So the capability is there, but it does take effort. Does that answer your question?
Yeah, different architectures, different structures will have different challenges. So
Yeah.
I'm just curious on how you approach it particularly.
Yeah, and you know, where we have, so, you know, again, he's just asking about our approach versus others, where we have invested heavily in time and money into figuring out how to do this. And since we're a university and all about educating folks, please feel free to reach out to us at this contact info, and we would be happy to share our experiences. We're working on white papers and documentation and things like that that can benefit the community generally. It's a great thing about being a nonprofit, right? We're happy to share. So we lost our volunteer, but let's go here. Oh, wait, well, we don't have microphones anyway. Okay, go ahead.
I wanted to ask, before you decided on going with Google's BigQuery, did you look at any other technology like Amazon Redshift or Hadoop?
We did.
Paraphrased.
We did. What's that?
Rephrase.
Oh, yeah, sorry. So the question is, before we chose BigQuery, did we look at other technologies, Redshift, which is Amazon's data warehouse in the cloud, and Hadoop, which most of you are familiar with? We did, and I can tell you why we fairly quickly decided that BigQuery was where we wanted to be. One, Redshift is very powerful, but it is not quite the no-ops solution that BigQuery is. There is still this activity of sort of provisioning your cluster, right? And that's very flexible, and what Amazon has done there is very impressive, but there's still more sort of nuts and bolts and turning things around in order to make sure that you always have the performance that you need when you need it. And with BigQuery, there's literally none of that. And where so much of what was motivating us were these enormous costs in the tuning and management of the underlying infrastructure, we found the BigQuery no-ops solution, literally load the data, start writing queries against it, don't worry about what the underlying infrastructure was, very, very appealing. The second thing, and this is very specific to us, I talked about the use of this molecular data. There's a component that sits next to BigQuery that's very specific to Google called Google Genomics. So anybody who's working with genomics data should take a look at this. It provides a great deal of capability around processing of genetic data. But for us, what it does is it gives us an easy way to sort of load genetic data up to the Google Cloud and link it to the rest of our data in BigQuery. We have Tableau dashboards right now that let us do things like define a certain type of patient by age and race and gender and ethnicity, and then have it come back and tell us what genetic mutations does that group of people tend to have in common. And that's enabled by Google Genomics. So those things together were really what sort of laser focused us on Google versus other solutions. Hadoop is great. Our data starts out structured, ends structured, and for the money, I don't think that there is anything faster and more performant and easier to manage and work with than BigQuery if that's the use case. If you have unstructured data, you know, there are other scenarios where Hadoop may be a better solution, but for us, BigQuery was the answer.
There's a question just here. Oh, no, there isn't.
Go ahead.
So what's the tool you use to load the data?
Okay, that's a good question. So what's the tool that you use to load the data? This is one of the weaknesses in the BigQuery ecosystem as we see it, but one that we hope is going to be resolved in the near future. We literally write Python scripts that use the BigQuery API. It's a REST API that automate the process of extracting data and then uploading it into the cloud. We do that manually. There are tools like Informatica, Talend, and other tools that will automate that for you in a more elegant fashion. We have some very specific complaints about the way that those tools work. We don't think they're quite yet fully optimized for BigQuery, and if you want to dig into those details, we're happy to do that. But right now, we're doing it with, you know, sort of a manually developed command line driven system, which turns out to have been fairly easy to build and works really well. But we look forward to the day when we can adopt some more elegant solution.
So where you had to try to compare the performance, right, before and after. So where's the performance in that part?
So comparing, so looking at the
Load the data, yeah.
Yeah. So loading the data into BigQuery is indisputably faster, even using our sort of homemade loading scripts, than it is loading the data into our traditional on-premises system by probably a factor of 2 to 1. Remember that those bars were end-to-end, including loading the data and including uploading the data through the internet onto the Google Cloud. Does that help?
Google BigQuery doesn't only provide API, right? You still need to do some coding to load the data, right?
You can, I'll take a question.
Sure. You should repeat the question.
Yeah, thank you. So the question is, do you need to do any coding to load data into BigQuery, or can you just, or is there a more facile tool? The most prominent way to get it in, like you can drag and drop to get stuff into GCS, and then there's a command line tool. The command is actually BQ space load. So if you want to load data, you can do it with just one line, but it is a command line.
For ad hoc analyses, you've got a great big spreadsheet and you just want to chunk away on that. You can do that completely through the web-based BigQuery analysis, BigQuery interface that Chad demoed. What we're talking about with needing to write scripts or things like that is really in the enterprise context when you want to automate processes. And you can do that yourself, or you can adopt one of the tools, again, like Informatica or Talend that supports it.
Were there any other questions?
We have a few more minutes.
I'll just use this moment then. The fellow in the blue striped shirt in the corner, Naveen, put your hand up. So Naveen brought little cards that are worth, they are actually, no kidding, $300 bills that you can only redeem with Google. So they're cards for credits if you want to poke around. But Naveen see Naveen for those, please.
Okay, thank you, everybody.